Hi students, welcome to Sankalp Learning Classes. In this session, we'll be going to discuss the 3-mark questions of chapter Matrices. We have already discussed the 1-mark questions and as well as the important points of this chapter. So straight away, we are going to discuss the questions. All right, so the first question is, find x and y, find x and y if x plus y equal to matrix 7025 and x minus y is equal to matrix 30 and 03. Here, what is x and y? X and y are matrices. All right, only we can add two matrices, right? Then only you will get a matrix. So x plus y is given as a matrix. So x and y are matrices. So they have given two equations, that is x plus y is equal to 7025 and x minus y is equal to 3003. And you have to find out the matrices x and y. So if you have got a equation, then how will you find out the values of x and y? You solve that equations, right? You solve the two equations and then find out the value of x. Similarly, here also there are two equations, right? X plus y and x minus y. So, like you solve an equation, you solve these two equations in order to find the matrices x and y. All right. So we are first going to add these two equations, right? X plus y is equal to matrix 7025 and then x minus y is equal to matrix 3003. Okay, so we are going to add these two equations. So if you add these two equations, then what is the value? X plus y and x minus y. If you add plus y and minus y gets cancelled, right? So x plus x will give you 2x, right? So the left side will become 2x is equal to, right? Now, how will you add two matrices? You have to add the corresponding elements in the same position, right? You have to add the corresponding elements in the same position. So, which means the first element will be the addition of 7 and 3. How will you get the first element? You should add the first element of both the matrices. So, what is the first element of the first matrix? It is 7. Then, first element of the second matrix is 3. So, if you add 7 and 3, you will get the value as 10. So, what is the first element of the new matrix? It is nothing but 10. Okay, so 7 plus 3 is equal to 10. Then you add the second element, 0 plus 0 is 0. Right. Now, add the third element. Can you see here? This is the third element. Then add this 2 with 0. If you add 2 with 0, the result is 2. Right. Now, add 5 plus 3. 5 plus 3 is equal to 8. So, you have got the value of 2x. Right. Now, you have to find out the value of x from that. We need the matrix x, right? So, you have to find out the matrix x from that. So, how will you find out the matrix x from that? You have to take the 2 to the right hand side, right? If you take 2 to the right hand side, it will become 1 by 2, right? So this will become x is equal to 1 by 2 of the matrix 10, 0, 2, 8. Then I hope you are all familiar with scalar multiplication of matrices, right? So how will you multiply this 1 by 2 with the matrix? You have to multiply each element of the matrix with 1 by 2. Isn't it? You have to multiply each element with 1 by 2. So the first element is 10. If you multiply 10 with 1 by 2, that is you are taking half of 10. So the first element will be 5, right? So this is equal to, the first element is 5 and then 0 by 2 is 0. Then 2 by 2 is 1. Now 8 by 2, 8 by 2 is 4. So what is the value of x or what is the matrix x? X is equal to matrix 5014. All right, now we have to find out the value of y. So how will you find out the value of y? You have already got the matrix x and there is an equation connecting x and y. So take any of those equations. Either you can take x plus y or you can take x minus y. Substitute the value of x in that equation, then you will get the value of matrix y, right? So here I'm going to take the matrix, the equation x minus y. Okay, x minus y equal to matrix 3003. All right. X minus y is equal to matrix 3003. Okay. So I'm going to put the value of matrix x that is 5, 0, 1, 2 minus y equal to matrix 3, 0, 0, 3. Okay, now you have to find out the value of y from this. So take this matrix to this side. Okay, so if I take the matrix in the right hand side to the left side, it will become minus, isn't it? Minus 3, 0, 0, 3. That is equal to, if I take this minus y to the right hand side, it will become plus y. So that is equal to matrix y. Now, how will you add, how will you subtract two matrices? You have to subtract the corresponding elements which are in the same position, isn't it? So you'll get the, how will you get the first element? You have to subtract 3 from 5. That is 5 minus 3. 5 minus 3 is equal to 2. 0 minus 0 is 0. Then 1 minus 0 is 1. And 2 minus 3 is minus 1. Okay, so the matrix y is nothing but 2, 0, 1, minus 1. Okay, I hope this question is clear to you all. Now we are moving on to the second question. So the second question is matrix A is equal to, matrix A is equal to 8, 0, 4 minus 2, 3, 6. And B is a matrix 2 minus 2, 4, 2, minus 5, 1. Okay, then find the matrix, then find the matrix, find the matrix X such that X such that 2A plus 3X is equal to 5. 2A plus 3X is equal to 5B. Okay, you have given two matrices A and B. All right, you have to find out the matrix X. How will you, and there is an equation connecting this A, B and X. And what is that? They have given that 2A plus 3X will give you 5B. From that equation, you have to solve the value of X, or you have to find out the matrix X. All right. So for that, first you have to substitute the given matrices in the equation, right? So what is the equation given? That is 2A plus 3x is equal to 5b. Okay, 2a plus 3x is equal to 5b. Now substitute the values of, here we know only the values of a and b, right? The matrix A and B are given. We don't know the value of x. We have to find it from this equation. Okay, so that is equal to 2 into matrix A is 8, 0, 4 minus 2, 3, 6, right? Plus 3 into x is unknown. Okay, that is equal to 5 into matrix B. Matrix B is nothing but 2 minus 2, 4, 2, minus 5, 1. Okay, now you have to find out the value of value of x from this. For that, first you have to multiply 2 into the first matrix, 2 into matrix A. How will you multiply 2 into matrix A? You have to multiply each elements with 2, right? So I'm taking a new page. We have to multiply 2 with each elements. So you will get 2 into 8, 0, 4 minus 2, then 3, 6 plus 3x is equal to 5 into 2 minus 2, 4, 2, minus 5 and 1. Okay, so 2 into 8 will give you, the first element is 16. 2 into 0 is 0, then 2 into 4. Okay, I hope it is clear to you all. 2 into 4. 2 into 4 is 8. 2 into minus 2 is minus 4. Okay, then 2 into 3, then 2 into 6. Then you will get the corresponding elements. So 2 into 4 is equal to 8. 2 into minus 2 is minus 4. 2 into 3 is 6 and 2, 6 are 12. Plus 3 into x is equal to 5 into the matrix B. How will you multiply? You have to multiply each element with 5. Okay, each element of matrix B with 5. So you'll get the resultant matrix. So 5 into 2 is equal to 10. Then 5 into minus 2 is minus 10. 5 4s are 20. Then 5 2s are 10. 5 into minus 5 is minus 25. Then 5 into 1 is 5. Okay, now what you have to do? You have to find out 3x from that. Okay, so for that I'm taking 3x, I'm putting placing 3x there itself and taking the matrix from the left side to the right side. Okay, so that is 3x is equal to 10 minus 10, 20, 10, then minus 25, then 5, minus 16, 0, 8 minus 4, 6 and 12. Okay, so this is equal to, the first value will be, you have to subtract the first elements, isn't it? So 10 minus 16. 10 minus 16 is nothing but minus 6. Then minus 10 minus 0. Minus 10 minus 0 is minus 10 itself. 20 minus 8 is 12. 10 minus minus 4 is 14. Minus 25 minus 6 is minus 19. Just 6, right? Minus 25 minus 6. Minus 25 minus 6 is, you have to add 25 with 6. So it will be 31. Minus 31. Then 5 minus 12 is minus 7. Alright. Okay. Now we have got the value of 3x, isn't it? Now we have got the value of 3x. From this, you have to find out the value of x. So how will you find out the value of x? You have to multiply the resultant matrix with 1 by 3, right? So then you will get the value of x. Okay. So x is equal to, I'm taking this 3 to the right side. Okay. So 1 by 3 of minus 6 minus 10, 12, 14, minus 31, minus 7. So that is equal to matrix minus 6 by 3, minus 10 by 3, then 12 by 3, 14 by 3, minus 31 by 3, then minus 7 by 3. Okay, so here minus 6 by 3 is nothing but minus 3. Minus 10 by 3 can be written like that itself. 12 by 3 is 4. 14 by 3 is written like that. Then minus 31 by 3, then comes minus 7 by 3. So now we have got the value of x as that 2a plus 3x is equal to 5b. Alright, now we are moving on to the third question. Third question has two parts. Okay, the first part is, if matrix A is equal to cos alpha sin alpha minus sin alpha cos alpha, then verify that A transpose A is equal to I. Okay. Second part we'll discuss later. So first we can finish the first part of that question. All right. So A is equal to, they have given a matrix and we have to verify A transpose A is equal to I. What do you mean by this I? I is nothing but the identity matrix. And what is the peculiarity of an identity matrix? In identity matrix, we know that the diagonal elements, all the diagonal elements will be 1 and all the non-diagonal elements will be 0. So you have to verify that A transpose into A. That is, if you multiply A transpose with A, you will get the identity matrix. Okay. So for that, first we have to find out the transpose of the given matrix, right? So how will you find out the transpose of a given matrix? You have to rearrange the rows as columns. Okay, you have to rearrange the matrix given, the rows of the matrix given as the column of the matrix. Then you will get the transpose of a matrix. Okay, so first we have to find out the transpose, that is A transpose. A transpose is equal to, the first row is, what is the first row? First row is this one, right? Cos alpha sin alpha. And now I am going to rearrange this into column, cos alpha sin alpha. And the second row is minus sin alpha and cos alpha. So this is our A transpose. All right, now what we have to do, we have to multiply this A transpose with A. Okay, so A transpose into A is equal to, so this is cos alpha sin alpha, then I'm sorry, A transpose is cos alpha minus sin alpha, and this one is sin alpha cos alpha into matrix A is cos alpha sin alpha, then minus sin alpha cos alpha. Okay. Now just multiply. How will you multiply two matrices? You have to multiply the first row with first column, then you'll get the first element of the resultant matrix. Okay, first row, when you multiply first row with first column, you will get the first element of the resultant matrix. So what is the first column row here? First row is this, and the first column of the matrix is this one. All right, now you have to multiply these row and column. So that is equal to cos alpha into cos alpha, right? Cos alpha into cos alpha, then minus sin alpha into minus sin alpha, that is plus sin alpha into sin alpha. So this is our first element. Now what you have to do, you have to multiply the first row with the second column. First row with the second column. So cos alpha into sin alpha, cos alpha into sin alpha, then minus sin alpha into cos alpha, minus sin alpha into cos alpha. Okay, now you consider the second row. Second row, you multiply the second row with the first column of the second matrix. Okay, then you'll get the third element. So sin alpha into cos alpha, sin alpha into cos alpha, then this one cos alpha into minus sin alpha. So that is the result is minus minus cos alpha sin alpha. All right. Now you multiply the second row with the second column. So sin alpha into sin alpha plus cos alpha into cos alpha. Okay. Now, can you find out the values of these one? Cos alpha into cos alpha means how can you write this one? Cos alpha into cos alpha. It can be written as cos alpha the whole square or cos square alpha, right? Both are same. So I'm going to replace this. So this matrix can be written as this cos alpha into cos alpha. I'm going to write this one as cos alpha the whole square or cos square alpha. Both are same, right? Plus sin alpha into sin alpha. It is nothing but sin square alpha. Sin square alpha. Okay, so now what is the value of this one? Cos alpha sin alpha minus sin alpha cos alpha. Both are same, right? Both are same. If you subtract the same values, then the resultant value is 0, isn't it? So the second element is nothing but 0. Now what about the third element? Third element is also like that, sin alpha cos alpha minus cos alpha sin alpha. So they both are same values. If you subtract same values, we'll get 0. So the third element is also 0. Now what about the fourth value? Sin alpha into sin alpha is nothing but sin square alpha. Sin square alpha plus cos alpha into cos alpha is cos square alpha. Okay. So what about cos square alpha? What is the value of cos square alpha plus sin square alpha? We have already studied the identity, right? Cos square x plus sin square x is 1. Here in place of x, you can see the angle is alpha. So it also satisfies the same value, isn't it? So cos square alpha plus sin square alpha is equal to 1. So the first element is 1. Second element is already, we have got it as 0. Third element is already 0. Now what about the fourth value? Fourth value is also the identity sin square alpha plus cos square alpha. So the value is nothing but 1. Okay. Now, what is the peculiarity of the matrix that we have now obtained? The resultant matrix. The resultant matrix is nothing but our identity matrix, isn't it? Here you can see that the diagonal elements, all the diagonal elements are 1 and the non-diagonal elements are 0. So what is the peculiarity of such type of matrix? It is nothing but our identity matrix. So this is equal to I. Okay. So the value is I. Which value? A transpose. If you multiply A transpose with A, you will get identity matrix. Okay. So we have verified that result. Now we are moving on to the second part of the third question. Second part of the third question is, if A is equal to, if A is equal to sin alpha cos alpha, then minus cos alpha sin alpha. So this is a different matrix. Okay. Different matrix with the elements are sin alpha and cos alpha. Okay. So A is equal to sin alpha cos alpha minus cos alpha sin alpha. Now we have to verify that. The question pattern is saying verify that A transpose A is equal to I. All right, we have to verify A transpose A is equal to I. So for that, we have to find out A transpose. What is A transpose? You have to rearrange the rows as columns, right? Then you'll get the transpose of a matrix. So sin alpha and cos alpha is the first row. You have to rearrange it as a column. So it will become sin alpha cos alpha. Now the second row will become minus second row of the matrix A will become the column of the transpose matrix. All right. So minus cos alpha, sin alpha. So this one is our matrix A transpose. Now what we have to do, we have to find out A transpose into A. A transpose into A. Okay. A transpose into A. How will you do that? We have already done in the previous question. You have to multiply these two matrices. Okay. So this was our A transpose. Now we have to multiply it with A. So sin alpha, this is cos alpha, then minus cos alpha, sin alpha. So how will you get the first element? You have to multiply the first row with the first column. All right. So sin alpha into sin alpha, sin alpha into sin alpha. Then minus cos alpha into minus cos alpha will become plus, right? Plus cos alpha into cos alpha. Then you have to multiply the first row with the second column. First row with the second column. Then you'll get the second element. So sin alpha, cos alpha minus cos alpha, sin alpha. Then the second row is cos alpha, sin alpha minus sin alpha, cos alpha. And the fourth one is cos alpha into cos alpha plus sin alpha into sin alpha. All right. Now, what is the value of sin alpha into sin alpha? It is nothing but sin square alpha. Sin square alpha plus cos square alpha. Cos alpha into cos alpha is cos square alpha. And what about the value of this one? Sin alpha cos alpha minus cos alpha sin alpha. The resultant value is 0. So this one becomes 0. And the third element is also 0. And what about the fourth element? Cos alpha into cos alpha can be written as cos square alpha. Sin alpha into sin alpha can be written as sin square alpha. Okay. Now, what is sin square alpha plus cos square alpha? It is an identity. What is the value of that identity? It is nothing but 1. So the first element is 1. Then this one is 0. Third is also 0. And cos square alpha plus sin square alpha is also 1. So what is the peculiarity of this matrix? It is nothing but our identity matrix. So we have all verified A transpose into A is equal to I for the second matrix also. Okay, so this was our third question. Now we are moving on to the fourth question. Fourth question is show that matrix 1, 2, 3, 0, 1, 0, 1, 1, 0. Okay, into minus 1, 1, 0, 0 minus 1, 1, 2, 3, 4 is not equal to, it is not equal to minus 1, 0, then 0 minus 1, 1, 2, 3, 4 into 1, 2, 3, 0, 1, 0, then 1, 1, 0. Okay. So you have to show that the matrix multiplication given in the left side is not equal to the matrix multiplication of the right side. Okay, so first we have to find out the resultant matrix when you multiply these two matrices in the left side, right? So first of all, consider the left part of the question, that is matrix 1, 2, 3, 0, 1, 0, 1, 1, 0 into matrix minus 1, 1, 0, 0 minus 1, 1, 2, 3, 4. Okay. So how will you multiply? You have to first consider this row. Okay. This row into this column. Okay. That is first row into first column will give you the first element. So I'm going to multiply these matrices. That is 1 into minus 1, right? 1 into minus 1 is nothing but minus 1 plus 2 into 0 is 0. Then 3 into 2 is 6. Now consider the second column, first row with second column. Then you will get the second element of the matrix. Okay, first row is 1. 1 into 1 is 1. Then 2 into minus 1 is minus 2. 3 into 3 is plus 9, right? Now consider the third row, sorry, the third column. First row into third column will give you the third element. So 1 into 0 is 0. Then 2 into 1 is 2. Then 3 into 4 is 12. Right? So we have got the first row of the resultant matrix. Now we have to find out the second row. So how will you find out the second row? For that you have to consider the second row of the first matrix and the first column of the second matrix. Okay, so we'll get the first element. That is 0 into minus 1 is 0. 1 into 0 is also 0. Then 0 into 2 is also 0. Right? Now, consider the second column. Second column with the second row. That is 0 into 1 is 0. Minus 1 into 1. That is minus 1. 0 into 3 is 0. Now 0 into 0. That is the third column. Then 1 into 1 is 1. Plus 0 into 4 is 0. Okay, now consider the third row. Third row with the first column. Third row with the first column will give you the value as 1 into minus 1 is minus 1. Then 1 into 0 is 0. And then 0 into 2 is 0. Okay, now consider the first row and the second column. So 1 into 1 is 1. Then minus 1 into 1 is minus 1. Then 0 into 3. 0 into 3 is nothing but 0. Now consider the third row and the third column. Okay, so 1 into 0 is 0. Then plus 1 into 1 is 1. And then 0 into 4 is 0. Okay, now what is the value? Minus 1 plus 6. Minus 1 plus 6 is nothing but 5. Then 1 minus 2 is minus 1. Minus 1 plus 9 is 8. Right? You have to subtract the smaller value from the bigger value and then you put the sign of the greater value, right? So it is minus 1 plus 9. So 9 is greater. 9 minus 1 is 8. And what is the sign of 9? 9 is plus, right? So it is plus 8. Now 2 plus 12 is 14. Then this one is 0. This is minus 1. This is 1. Then this one is minus 1. 1 minus 1 is 0. Then 1. So what is our matrix? 5, 8, 14, 0, minus 1, 1, minus 1, 0 and 1. Okay, so this is the left hand side of that equation. Now what you have to do, you have to find out the multiplication that is given in the right side also, right? So for that we can take a next page. Okay, so consider the right side of the question. Right side is nothing but minus 1, 1, 0, then 0, minus 1, 1, 2, 3, 4 into the second matrix is 1, 2, 3, 0, 1, 0, 1, 1, 0. Okay. Now I'm going to multiply the first row with the first column. You'll get the first element. Okay. So this is our first row and this is our first column. Okay. So minus 1 into 1 is minus 1 plus 1 into 0 is 0. Then 0 into 1 is 0. Then minus 1 into 2 is minus 2 plus 1 into 1 is 1 and 0 into 1 is 0. Minus 1 into 3 is minus 3 plus 0 plus 0. Right? Now you have to consider the second row and then you multiply it with the first column. Okay, so this is our second row. This is our second row. Okay, 0 into 1 is 0. Then minus 1 into 0 is also 0. Then 1 into 1 is nothing but 1. Now consider the second column. 0 into 2 is 0. Then minus 1, 1 into 1. That is minus 1. Then 1 into 1 is 1. Now, in order to get the third element, you have to consider the third column. So 0 into 3 is 0. Then all the other values are 0, right? Minus 1 into 0 is also 0. 1 into 0 is also 0. Now, take the third row and the first column. Third row is 2. So 2 into 1 is 2 plus 3 into 0 is 0 and 4 into 1 is nothing but 4. Now 2 into 2 is 4 plus 3 into 1 is 3 and plus 1 into 4 is 4. Now 2 into 3 is 6 plus 3 into 0 is 0 and 4 into 0 is also 0. Alright, now what are the values? The first one is minus 1, minus 2 plus 1 is minus 1, minus 3 plus 0 is minus 3. This one is 1, this is 0 and this is also 0. 2 plus 4 is 6. 4 plus 4, 8. 8 plus 3 is 11. Then 6. Okay, so this is our matrix. Minus 1, minus 1, minus 3, then 1, 0, 0, 6, 11, 6. Okay, so are the matrices, resultant matrices equal? No, both are different, right? First we have got 5, 8, 14, then 0, minus 1, 1, then minus 1, 0, 1. This is not equal to the second matrix. Minus 1, minus 3, 1, 0, 0, 6, 11, 6. 6, 11, 6. All right. Now we are moving on to the fifth question. That is, if matrix A is equal to, if matrix A is equal to minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1, then B is equal to minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Okay. Then you have to verify that. Then verify that the first part is A plus B, A plus B, the whole transpose is equal to A transpose plus B transpose. And the second one is A minus B, the whole transpose is equal to A transpose minus B transpose. All right. So first you consider the first part of the question. That is A plus B, the whole transpose is equal to A transpose plus B transpose. You have to verify that thing. Okay. So for that, first you have to find out what is A transpose and what is B transpose. Similarly, you have to find out A plus B. And then you have to find out the transpose of A plus B also. Okay. So first you can find out the value of A plus B. Okay. A plus B. What is A plus B? You have to add the matrices given, that is minus 1, 2, 3, then 5, 7, 9, then minus 2, 1, 1, plus what is matrix B? Matrix B is minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Okay, how will you add two matrices? You have to add the corresponding elements. So, if you add the corresponding elements, the resultant matrix is, you add minus 1 with minus 4. So, what is the value? It is nothing but minus 5. Then 2 plus 1 is 3. Then 3 minus 5 is minus 2. Then 5 plus 1 is 6. 7 plus 2 is 9. And 9 plus 0 is also 9. Okay, now consider the third row. Third row, if you add 2 with 1, it is 3, then 1 plus 3 is 4, then 1 plus 1 is 2. So what is A plus B? A plus B is nothing but the matrix minus 5, 3, minus 2, 6, 9, 9, and then it is actually, it is minus 2. Okay, minus 2 plus 1, right? Minus 2 plus 1 is, sorry, it is not plus 2. Okay. This minus 2 plus 1. Minus 2 plus 1 is nothing but minus 1, right? So minus 1, then 4, and then 2. Okay. So we have got the matrix A plus B. And what about A plus B, the whole transpose? What is the transpose of this particular matrix? You have to rearrange the rows as columns, right? So the first row, minus 5, 3, 2 will become the first column of this matrix, right? Now the second row is 1, 9, 9, right? I'm sorry, it is 6. It is 6. 6, 9, 9. And then minus 1, 4, 2. Minus 1, 4. So this is our A plus B, the whole transpose. Now what you have to do, you have to find out the right side of the equation. What is the right side? It is nothing but the sum of A transpose and B transpose. So for that, you have to first find out the transpose of the matrix A, right? So first you have to find out the transpose of matrix A. A transpose. Okay, A transpose is, you have to rearrange the rows as columns, right? So what was our matrix A? Our matrix A was minus 1, 2, 3 was the first row. So it becomes the first column. Minus 1, 2, 3 is the first column. Then 5, 7, 9 is the second column. Then minus 2, 1, 1 is the third column. Okay, now what about B transpose? B transpose is also like that. That is minus 4, 1, minus 5 is the first row of the matrix B. So what about the first column of B transpose? Same, right? So that is equal to minus 4, 1, minus 5, then 1, 2, 0, then 1, 3, 1. So this is our matrix B transpose. And what about A transpose plus B transpose? You have to add these two matrices. How will you add the two matrices? You have to add the corresponding elements. So if you add the first element, minus 1 with minus 4, the resultant value is minus 5. 5 plus 1, 5 plus 1, 6, minus 2 plus 1 is minus 1, 2 plus 1, 3, 7 plus 2, 9, 1 plus 3 is 4, 3 minus 5 is minus 2, 9 plus 0 is 9, and 1 plus 1 is 2. So the matrix is minus 5, minus 5, 6, minus 1, 3, 9, 4, minus 2, 9, 2. All right, so what was our previous matrix? That is A plus B. We have found out A plus B the whole transpose. That was also minus 5, 6, minus 1, 3, 9, 4 and minus 2, 9, 2. Okay, so we have verified the equation. A plus B the whole transpose is nothing but A transpose. Both are same, right? So we can write A plus B the whole transpose is equal to A transpose plus B transpose. All right, now we are moving on to the second part of this question. Okay, second part is we have to verify A minus B the whole transpose is equal to A transpose minus B transpose. Okay, for that we need matrices A, right? So matrix A is nothing but minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. And what about matrix B? Matrix B is equal to minus 4, 1, minus 5, 1, 2, 0, and 1, 3, 1. Now you have to first consider the left side of the equation, that is A minus B the whole transpose. For that you have to find out what is A minus B, right? So A minus B is equal to, you subtract those two matrices. How will you subtract two matrices? You have to subtract the corresponding elements. So minus 1, minus 4. Minus 4 is minus 5, right? Now, what about the second element, 2 minus 1, right? 2 minus 1 is 1. 3 minus minus 5, isn't it? 3 minus minus 5. So first, I think you can write it like this. Okay, A minus B. Okay, so 3 minus minus 5 is 3 plus 5. So the value is 8, right? Now, consider the second row. 5 minus 1. 5 minus 1 means 4. Then 7 minus 2 is 5. Then 9 minus 0 is 9 itself. Then minus 2 minus 1 is minus 3. 1 minus 3 is minus 2. 1 minus 1 is 0. Alright, so what is A minus B? We have got A minus B as 318. Okay, is there any problem here? Minus 1 minus minus 4. First element itself. You can see that minus 1 minus minus 4 is minus 1 plus 4. Minus 1 plus 4 means you have to subtract the smaller value from the bigger value, right? So 4 minus 1 is 3. And what is the sign of the larger value? Sign of the larger value is nothing but minus. So it is actually plus 4. It is plus. Okay, so this one is actually wrong. It is not minus 5. It is minus 1. You can see here minus 1 minus minus 4, that is minus 1 plus 4. This value is 3. Okay, so this one is 3. So it is 318. Then second row is 459 and the third row is minus 3 minus 2 0. All right, now we have to find out A minus B the whole transpose, the transpose of the matrix. So the transposes, you have to rearrange this first row as column 318, then 4 5 9, then this one is minus 3 minus 2 0. So this is our A minus B the whole transpose, matrix A minus B the whole transpose. Now what we have to do, we have to find out A transpose minus B transpose, right? For that we have to find out A transpose. First of all, what is A transpose? A transpose we have already found out, it as minus 1 5 minus 2, then 2 7 1, then 3 9 1. Okay, and B transpose is equal to minus 4 1 1 1 2 3 minus 5 0 1. Okay, so this is our B transpose. And A transpose minus B transpose means we have to subtract these two matrices. Okay, so minus 1, I'm putting a minus here. Okay, so minus 1 minus minus 4. Okay, you can write this as another step. That's better, I think. Otherwise, you'll make mistakes. Okay, so minus 1, 5 minus 2, 2 7 1, 3 9 1 minus. Okay, so here you can see a minus 4 1 1 1 2 3 minus 5 0 1. All right, now minus 1 minus minus 4 is minus 1 plus 4. The value is 3. Then 5 minus 1 is 4. Minus 2 minus 1 is minus 3. Then 2 minus 1 is 1. 7 minus 2 is 5. Then 1 minus 3 is minus 2. Right. 3 minus minus 5 is 8. Now 9 minus 0 is 9, and then 1 minus 1 is 0. Okay, so this is our A transpose minus B transpose. It is 3, 4 minus 3, 1, 5 minus 2, 8, 9, 0. And what was our A minus B, the whole transpose? A minus B, the whole transpose is 3, 4 minus 3, 1, 5 minus 2, 8, 9, 0. From this, you have got that, what you have got? A minus B, the whole transpose is equal to, A minus B, the whole transpose is equal to nothing but A transpose minus B transpose. All right. Now, we are moving on to the next question. It's a sixth question, right? If A is equal to matrix 3 minus 2, 4 minus 2, okay, and I is equal to matrix 1, 0 and 0, 1, find, find K, find K, so that, A square is equal to KA minus 2I. Okay, so here in this question, you have given the matrix A and I is a 2 by 2 identity matrix, and you have to find out the value of K such that A square is equal to KA minus 2I. Okay, so how will you do that? In the equation, there is the matrix A, then an identity matrix, and then an unknown value K. Isn't it? Here A and I is known. So substitute that values in the equation and then you find out the value of K. Right. So here A into A can be, A square can be written as A into A. Right. So this one is equal to A square is equal to A into A. Right. A into A is equal to, what is A into A? 3 minus 2, 4 minus 2 into the matrix 3 minus 2, 4 minus 2. Okay. Multiply the first row with the first column. So that is 3 into 3 is 9. Then plus, sorry, it is minus, right? Minus 2 into 4 is minus 8. Now, 3 into minus 2 is minus 6. Then minus 2 into minus 2 is plus 4. Now consider the second row and the first column. So 4 into 3 is 12. Then minus 2 into 4 is minus 8, right? Then 4 into minus 2 is minus 8. Then minus 2 into minus 4 is nothing but plus 4, right? So what is the value? 9 minus 8 is 1. Minus 6 plus 4 is minus 2. Then 12 minus 8 is 4. And what is minus 8 plus 4? It is nothing but minus 4. So, what is A square? 1 minus 2, 4 minus 4. Okay. Now what you have to do, you have to find out the right side. That is KA minus 2I. KA minus 2I. Okay. K into A minus 2 into I. So that is equal to K. We don't know the value of K. And what is A? 3 minus 2, 4 minus 2 minus 2 into I. I is a 2 by 2 identity matrix. 2, that is 1, 0, 0, 1. Okay. Now, this is scalar multiplication, isn't it? The scalar value is K. So, multiply each elements with K, right? So, the first element will be 3K. Then minus 2 into K is minus 2K. 4 into K is 4K. Then minus 2 into K is minus 2K. Minus 2 into 1 is 2 into 1 is 2, right? 2 into 0, 0. Then 0. Then 2 into 1 is again 2. So what is the value? You have to subtract the corresponding elements. So 3K minus 2. The first element will be 3K minus 2. Second element is minus 2K minus 0. That is minus 2K itself. Then 4K minus 0 is 4K minus 2K minus 2. Okay. Now, this is equal to, they have already given that this value is equal to A square. And what was our A square? They have given that A square is equal to KA minus 2I, right? So this is KA minus 2I. Now, and we have already found out the value of A square. What was A square? A square is equal to 1 minus 2, 4 minus 4. So this one will be equal to, this one can be equated to the matrix 1, minus 2, 4 minus 4, right? It is given in the question. Now you take any value, any corresponding values. I'm taking 3k minus 2 is equal to 1. 3k minus 2 is equal to 1. On solving this equation, you'll get the value of k, right? So this is equal to 3k is equal to 1 plus 2. What is 1 plus 2? Nothing but 3. 3k is equal to 3. So what is the value of k? K is equal to 3 by 3. What is 3 by 3? It is nothing but 1. So what is the value of k? K is equal to 1. Okay. Now we are moving on to the seventh question. Prove that for any square matrix A, for any square matrix A with real number entries with transpose is a symmetric matrix. It is a symmetric matrix, and A minus A transpose is a skew symmetric matrix. Okay. So this is a general result and we have to prove this. For that, let's consider the first part. What is the first part? We have to prove A plus A transpose is a symmetric matrix. Let us put this A plus A transpose as B. Okay. It is for uh, earning easiness to solve the question. Okay. So I'm taking this A plus A transpose as B. B is equal to A plus A transpose. Now what we have to prove? This one is a symmetric matrix. So how will you prove that a matrix is a symmetric matrix? You have to get, if you are given a matrix A, if A transpose is equal to A, you can say that it is a symmetric matrix, right? So similarly, we have here we have taken this A plus A transpose as B. So this one should satisfy the condition B transpose is equal to B. Then we can say that B is a symmetric matrix, right? So for that, first we can consider the transpose of the matrix B. Okay, B transpose. And what is this B? B is nothing but A plus A transpose, the whole transpose, right? So this can be splitted as A transpose plus this transpose can be given to the, okay, here. This transpose can be given to the second element also, isn't it? So this will become A transpose, the whole transpose. And A transpose is A transpose itself. And what about A transpose, the whole transpose? It is nothing but A. And what about the value? A plus A transpose. A plus A transpose is nothing but B, right? The matrix B. So we have got it as B. And from this you have got B transpose is equal to B, which implies from this you can say that B is a symmetric matrix, right? B is a symmetric matrix. And what is this B? What is this B? We have given it as A plus A transpose, right? So A plus A transpose is a symmetric matrix. A plus A transpose is a symmetric matrix. Okay, now we are moving on to the second part of the same question. Second part is we have to prove A minus A transpose. We have to prove A minus A transpose is a skew symmetric matrix. It is a skew symmetric matrix. And what is the condition for a matrix to be skew symmetric? What is the condition? If you are given a matrix A, it is skew symmetric if A transpose is equal to minus A. If A transpose is minus A, we can say that the matrix A is a skew symmetric matrix. All right. So here I'm going to put this A minus A transpose as C. Okay. Okay, C is equal to A minus A transpose. Now what you have to do, we have to find out what is this transpose of the matrix. Okay, so that is C transpose. What is C transpose? It is nothing but A minus A transpose, the whole transpose. Okay, and by the property of transpose, we can split this transpose or we can give the transpose to each of the elements, right? So A minus A transpose, if you give transpose to each of the elements, it will become A transpose minus A transpose, the whole transpose. Right? So A transpose is that itself. What about A transpose, the whole transpose? It will become A. Right? So this is A transpose minus A. And if I take a minus outside from this, so this can be written as minus of A minus A transpose. Minus of A minus A transpose. And what is this A minus A transpose? It was C, right? So this can be written as minus C. So now what we have got? We have got that C transpose is equal to minus C. From this you can conclude that C is a skew symmetric matrix, right? We can conclude that C is a skew symmetric matrix. Okay, which means what is C? C is A minus A transpose, isn't it? A minus A transpose is a skew symmetric matrix. Okay. So they have asked that to verify A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. So both are true, isn't it? So we have now proved that A plus A transpose is symmetric as well as A minus A transpose is a skew symmetric matrix. All right. Now what we have to do is that some certain questions they'll give you a matrix and then they'll ask to verify the same result. That is for specific values. Now we have proved it for general value. Sometimes they'll ask specific values. That is they'll give certain matrices and they'll ask you to verify these results. Okay. So we'll do such a problem also. That is for the matrix A is equal to for for the matrix the matrix A is equal to matrix 1 5 6 7 verify that first one is A plus A transpose is a symmetric matrix. A plus A transpose is a symmetric matrix, and the second one is A minus A transpose is a skew symmetric matrix. Okay, so both part you have to prove. So what is the peculiarity? You have given the matrix A, right? So for that, first you have to find out the A transpose, right? So what is A transpose? A transpose is equal to, the first row is 1, 5. So make it as a column. So you'll get the transpose, right? So 1, 5 is the column. Then 6, 7. A transpose is 1, 6, 5, 7. All right. Now, what is A plus A transpose? You have to add these two matrices, right? So 1 plus 1 is 2 and 5 plus 6 is 11. 6 plus 5 is also 11. 7 plus 7 is 14, right? So this is our A plus A transpose. And how will you prove that it is a symmetric matrix? You have to consider the transpose of that matrix, right? So that is A plus A transpose, the whole transpose. What is the transpose of this matrix? You rearrange the row as column. So you will get 2, 11 will be the first column and 11, 14 is the second column, right? So this is our transpose of the matrix, and it is a symmetric matrix if it is A transpose. A is a symmetric matrix if A transpose is equal to A, right? So are they equal? This was our A, right? This was our matrix and the transpose is given here. Both are equal, right? So it satisfies the condition. And if in order to avoid confusion, you can take this A plus A transpose as B. Let A plus A transpose be B. Now we are finding out B transpose, right? Okay, B transpose, which means now we have got this one as B itself, right? So we have got B transpose is equal to B. So we can say that B is a symmetric matrix. And what is B? B was A plus A transpose. So A plus A transpose is a symmetric matrix. Now consider the second part of the question. In the second part, you have to verify A minus A transpose is a skew symmetric matrix, isn't it? So first of all, you have to find out what is A minus A transpose, right? So A is equal to 1, 5, 6, 7 and A transpose is equal to 1, 6, 5, 7, right? So I'm going to subtract these two matrices. 1 minus 1 is 0. 5 minus 1 is 5 minus 6. 5 minus 6 is minus 1. Then 6 minus 5 is 1. 7 minus 7 is 0. So 0 minus 1, 1, 0. This is the A minus A transpose. Now we have to prove that it is a skew symmetric matrix. And what is the condition of a skew symmetric matrix? That is, a matrix A is said to be a skew symmetric matrix if A transpose is equal to minus A. Now here I am going to take this A minus A transpose as matrix C. Okay. A minus A transpose. It is just to avoid confusions. Now what we have to get? We have to get C transpose is equal to minus C. Then we can say that C is a skew symmetric matrix, right? So what is the transpose of this matrix? A minus A transpose, the whole transpose. That is equal to, you have to take the transpose of this particular matrix. Okay, rearrange the row as column. So this will become 0, 0, 1, minus 1, 0. Okay, so in this, from this I am going to take a minus outside. So this will become 0, minus 1, 1, 0. And what is the matrix, this one? It is nothing but C, right? Isn't it? 0, minus 1, 1, 0. So this is equal to minus C. Is equal to minus C. So we have got C transpose is equal to minus C, which implies C is a skew symmetric matrix. And what is C? C was A minus A transpose. So A minus A transpose is a skew symmetric matrix. All right. Now we are moving on to our next question. I think it is our ninth question. Okay. Moving on to our ninth question. Prove that any square matrix can be expressed. Any square matrix can be expressed. I'm sorry. Just a minute. Prove that any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Okay, so any square matrix can be expressed as a sum of a symmetric and a skew symmetric matrix. Okay, so here we are proving it in as a general case. Okay, so for that I'm considering matrix A. Okay, I'm considering matrix A. Now what we have to do, we have to represent this A as a sum of a symmetric as well as a skew symmetric matrix. All right, so we know that from the previous result we have got that A plus A transpose. What is A plus A transpose? It is a symmetric matrix, right? A plus A transpose is a symmetric matrix. Now, what about half of A plus A transpose? Half of A plus A transpose is nothing but we are multiplying this A plus A transpose, matrix A plus A transpose with a scalar value 1 by 2. So that matrix will also be symmetric, right? So for example, if you consider 5, 4, 4, 10. Okay, 5, 4, 4, 10. So this is a symmetric matrix, right? It is a symmetric matrix because you can see that the non-diagonal elements are equal. That is Aij equal to Aji. The condition is satisfied. So this is a symmetric matrix, or you can verify it by checking A transpose is equal to A. All right. So if I multiply this matrix with a 1 by 2, what happens here? It will become 5 by 2. 4 by 2 is nothing but 2. Then this is also 2. What is 10 by 2 is nothing but 5. Here also you can see that this matrix, when I multiplied it with a 1 by 2, a scalar value, that is also, the resultant matrix is also a symmetric matrix, right? So we can say that half into A plus A transpose is also, it is also symmetric. It is also symmetric, isn't it? Now, what about A minus A transpose? We know that A minus A transpose is a skew symmetric matrix. It is a skew symmetric matrix. Okay. Okay, here you can also include the verification of the symmetric property. Okay, you can verify A plus A transpose as symmetric matrix. That is, when you answer this type of question, first you have to verify that A plus A transpose is a symmetric matrix. And then you write half of A plus A transpose is a symmetric matrix. Similarly, you should add the proof of A minus A transpose is a skew symmetric matrix also. Okay, then if you take half of this one, half of A minus A transpose, This is also a skew symmetric matrix. This is also a skew symmetric matrix. Okay, now I'm going to add these two matrices. That is, I'm going to add this half A plus A transpose, half of A plus A transpose with half of A minus A transpose. Okay, A minus A transpose. And now if I open the bracket, okay, that is, it will become half A plus half A transpose, right? I'm multiplying this half with each of the elements. Okay, half A plus half A transpose plus half A minus half A transpose. Okay, here you can see that these two values get cancelled, right? Half minus half A transpose and plus half A transpose gets cancelled. And what about the value half A plus half A? That is 1 by 2 A plus 1 by 2 A is nothing but A, right? A. Now, if I put this one as P, matrix P, and if I put this matrix as Q, that is half of A minus A transpose as Q, now what we have got? P plus Q, right? P plus Q is equal to A. So we have proved that any square matrix A can be written as a sum of a symmetric and a skew symmetric matrix. Alright, now we are going to do a specific problem. That is, you will be given a matrix and you have to verify the same result. Okay, that is matrix B is equal to express the matrix. The question will be express the matrix B is equal to 2 minus 2, 2 minus 2 minus 4, minus 1, 3, 4, 1 minus 2 minus 3. Okay, this is our matrix. And this one as the sum of a symmetric, and a skew symmetric matrix. Okay. So what is B transpose? From this you will get the value of B transpose, right? What is B transpose? You have to rearrange the row as column. So this is 2 minus 2 minus 4, minus 1, 3, 4, 1 minus 2 minus 3. So this is a B transpose. And what about B plus B transpose? Now I'll take in another page. Let P is equal to P is equal to half of B plus B transpose. Okay, we know that any matrix can be expressed as the sum of a symmetric and a skew symmetric matrix, and we have proved it in general that the symmetric matrix will be half of B plus B transpose, and the skew symmetric matrix will be half of B minus B transpose. So first you find out the value of half of B plus B transpose. That is nothing but half of, you can take this half outside. And what is this matrix B? Matrix B is 2 minus 2 minus 4, minus 1, 3, 4, 1 minus 2 minus 3 plus half of, okay, either you can do like this or you can take this half outside. Okay, that's better, I think. Then you can avoid a step. Okay, so if I take this one outside, you can write this one like this. B transpose is nothing but it is 2 minus 1, 1, then minus 2, 3, minus 2, minus 4, 4, and minus 3. Okay, so what is the value? You have to add these two matrices, and 2 plus 2 is 4, minus 2 minus 1, right? It is minus 3. Then minus 4 plus 1 is minus 3. Minus 1 minus 2 is also minus 3. 3 plus 3 is 6. 4 minus 2 is 2. 1 minus 4 is minus 3. Minus 2 plus 4 is 2. And minus 3 is nothing but minus 6. Okay. So if you multiply this each elements with 1 by 2, what is the resultant matrix? 4 by 2 is equal to 2 minus 3 by 2. This is also minus 3 by 2. The third element is also minus 3 by 2. Right? 6 by 2 is nothing but 3, and 2 by 2 is 1. Then minus 3 by 2. Then 2 by 2 is 1. Minus 6 by 2 is minus 3. Okay, so this is our matrix P. Now what we have to do, we have to find out the matrix Q also. Okay, we need a skew symmetric matrix. So for that, we have to find out a matrix Q such that it is equal to half of B minus B transpose. Here also I'm taking this half outside and then I'm putting the value of the matrix B and B transpose. Okay. So B is equal to B. What is B? B was 2 minus 2 minus 4. Then minus 1, 3, 4. Then this one is 1 minus 2 minus 3 minus matrix B transpose. That is equal to 2 minus 1, 1 minus 2, 3 minus 2 minus 4, 4 minus 3. Alright. Now you have to subtract these two matrices. So that is equal to half of 2 minus 2 means the matrix 0, right? First element will be 0 minus 2 minus 2 minus 1, that is minus 2 plus 1, so minus 1, right? Minus 4 minus 1 is minus 5, minus 1 minus minus 2 means minus 1 plus 2, so the value is 1. 3 minus 3 is 0, then 4 minus 2 is 2, 1 minus 4 is minus 3, minus 2 minus 4 it is 2, then minus 3 is minus 6. Okay. 0 minus 1 minus 5, 1 0. It is 106. 4 minus minus 2. It is actually 6, right? 4 plus 2 is 6. So minus, and then 1 minus minus 4 means 1 plus 4, right? You can write, actually, you can write a one more step, otherwise you'll make mistake. So you can write as in between step also you can write. Okay. 1 minus minus 4 is 1 plus 4, that is equal to 5. Okay. Now, minus 2 minus 4 is minus 6. It is minus 6. And then, okay, minus 3 minus, it is minus 3 minus minus 3, which means minus 3 plus 3. That is equal to 0. Okay. It's better you always write one more step. Okay. In between step also you can write it. Otherwise, here I'm making mistakes. Similarly, you can also make mistakes. So you can include that step also. Okay. That is subtracting step. Because here it is a minus. Sometimes you will just ignore that minus and then you'll get a wrong value. Okay. So this one is our matrix. And now what you have to do, we have to multiply each elements with 1 by 2. So the resultant matrix is 0. Then this one is minus 1 by 2. This is minus 5 by 2. Then it is 1 by 2. This is 0. 6 by 2 is nothing but 3. And uh, this you don't need to multiply this 1 by 2 actually. But here I'm doing it. That is 5 by 2. This one is minus 3 and this one is 0. You can actually find the answer from the previous step itself. Okay, I think that will be better in order to add those two matrices P and Q. Okay, so I'm taking next page. So this is our P was half of, I'm writing the step just above the answer. All right, that is half of 4 minus 3, then minus 3, 6, 2, minus 3, 2, minus 6, then plus half of 0, minus 1, minus 5, 106, then 5 minus 6, 0. Okay. Now if I add these, I'm taking this 1 by 2 outside, common. 1 by 2 is common, right? So 1 by 2 I'm taking outside and then now I'm adding the matrices. So 4 plus 0 is 4. Minus 3 minus 1 is minus 4. Then minus 3 minus 5 is minus 8. Minus 3 plus 1, it is minus 2. 6 plus 0 is 6. Then 2 plus 6 is 8. Minus 3 plus 5 is sorry, it is 2. Right, it is 2. And 2 minus 6 is minus 4. And what is minus 6 plus 0? It is minus 6. So the resultant values, now you can multiply each elements with 1 by 2. I think this will be better. Okay. For simplification, this will be better. So 4 by 2 is equal to 2. Minus 4 by 2 is minus 2. Then minus 8 by 2 is minus 4. Minus 2 by 2 is again minus 1. 6 by 2 is 3. 8 by 2, 4. 2 by 2 is 1. Minus 4 by 2 is minus 2. Minus 6 by 2 is minus 3. 2 minus 2 minus 4 minus 1. 3, 4, 1 minus 2 minus 3. All right. Okay. And what can you say about this matrix? This matrix. Isn't that our question? So we have expressed the matrix B as a sum of a symmetric and a skew symmetric matrix. Okay. B is written as P plus Q, where P is a symmetric matrix and Q is a skew symmetric matrix. All right. Now we are moving on to the last question of the session. That is the 11th question. If A and B, if A and B are symmetric matrices, they are symmetric matrices of the same order, of the same order, then show that, AB is symmetric, AB is symmetric if and only if AB is equal to BA. Okay, so we have to prove that A, B are symmetric matrix. That is given in the question. If A into B, the matrix multiplication A into B, that matrix is symmetric if and only if AB is equal to BA. What do you mean by that? That is AB is symmetric, then we can say that AB is equal to BA. And if AB is equal to BA, then we should show that AB is symmetric also. So there are two cases here. So first of all, the case 1 is considered. Okay, so case 1. And they have already given that A and B symmetric, right? A, B are symmetric. So we can write A transpose is equal to A and B transpose is equal to B, right? So this is a condition of a symmetric matrix. And now I'm supposing that, suppose AB is symmetric. So the first part is considered, okay? Suppose AB is symmetric. AB is symmetric. And what about AB, the whole transpose? It can be written as B transpose A transpose, right? So this is the property of transpose. AB, the whole transpose is nothing but B transpose A transpose, isn't it? So what is this B transpose, which is nothing but B, because B is a symmetric matrix. So B transpose is equal to B. And what is A transpose? A transpose is equal to A, because A is a symmetric matrix. So this is equal to BA, right? And what is this? AB the whole transpose. AB the whole transpose can be written as, just a minute, I have made a mistake. AB is symmetric, means AB the whole transpose is equal to AB. I forgot to write this condition. AB is symmetric means AB the whole transpose is nothing but AB, right? And now the same previous steps itself, right? So AB the whole transpose can be written as B transpose A transpose. That is equal to AB. Okay, so B transpose is equal to B and A transpose is equal to A. So that is equal to AB. Okay, now we have got the second part. That is, if I suppose that AB is symmetric, then we are getting BA is equal to AP. Now what we have to do? We have to prove the second part. What is the second part? That is, suppose AB is equal to BA. Hmm? AB is equal to BA. Now we have to prove that it is symmetric. That is, AB transpose is equal to AB, right? So consider AB the whole transpose. AB the whole transpose is B transpose A transpose, right? And what is B transpose? It is B, because B is a symmetric matrix. A transpose is A. And we have supposed that AB is equal to BA, right? AB is equal to BA. So this BA can be replaced with AB, right? So what is AB the whole transpose? AB the whole transpose is nothing but AB itself, which implies that AB is a symmetric matrix, right? AB is a symmetric. AB is a symmetric matrix. Okay. So that was the 3 mark questions from the chapter. And now we have completed the section. In the next session, we'll be discussing the 5 mark questions of the chapter matrices itself. I hope this session was useful to you all. Thank you.